All right.
I want my students to get really motivated about the topic today from start to end. I want to really make them excited about my next session, receive feedbacks from peers to make improvement on my lessons, and employ core-based cycle and engage the students through active learning. So that was all about my goal. I'll try to cover hopefully all in this session, but let me know when my time starts. Okay. Hello everyone. So my name is Abhishek Soni, and today I'll be taking you to a very exciting topic in chemistry, which is how to convert water to fuels, right? So first of all, my question to you all is, how many of you like chemistry? Or at least, wow, great. That's really exciting, and then I would, at the end of the session, I will really try my best to make even more exciting, okay? So, first, I would like to acknowledge UBC Point Grey campus, which is located on traditional, ancestral, and unceded territory of the Musqueam, and we're really grateful for that. But the learning outcome of today's session is that by the end of this lesson, you will be learning how to really generate fuel from water. So I think everybody uses water in their daily life, right? We really can't survive without water. But imagine we have so much of water on this land, right? And then we can really take use of that water and generate something very interesting like fuels or chemicals. And rather than burning fossil fuels, right, which generate a lot of carbon dioxide in the atmosphere, correct? So water is one of the greenest source of energy, and somehow we are ignoring the fact in today's world. So really want to take you through how we can use this, one of the abundant element on our earth to convert that into fuel. So here is an icebreaker for you. If you can guess how much of our Earth's surface is covered with water, I'll give you like maybe 20 seconds or maybe even 10 seconds just to raise your hand, just start putting any options. 70%. What about you?
I'll do the same.
Okay, great. So first of all, I would really encourage everyone to participate in this learning session, and then basically also, help me understand what your level of knowledge is on this regard. So really encourage you to do that. And the answer is correct. It's 70%. So probably I put this picture because to give you some insights on how much is land, how much is water. But we have 70% water on our Earth. And basically, it's so essential for our survival that we use it for drinking, aquatic life, swimming, fountains, in our cooking, also in our industries. Industries and laboratory research are using water in daily lives to produce something useful for humankind. So what I'll be focusing on industries, because that will basically actively working on use this green form of water, which is greenest form of energy, to convert into something useful. So I'm going to give you a sheet which I prepared. If you can take some time to write 2 uses of water in industry. Anything comes into your mind, just within like 10 seconds or maybe 20 seconds, but I'll keep it to 20 seconds. Just write that. No problem. And please let me know when you're done so that I can move forward. Okay, great. All right. So, in industries, I'm not sure how much of you know that this 70% of water you can really take from the seawater or from other sources of water or wastewater. You can really take them to convert something like hydrogen as a fuel. I'm sure you must be knowing about the hydrogen fuel generated cars, right? You can run cars with green hydrogen, correct? Everybody is aware of that, right? So basically, if people are not aware, I will just take some time to explain that, like China and some of the leading developing countries are really trying to focus their efforts on replacing the petrol with green hydrogen to drive their cars. And water can be used as a source to generate hydrogen as fuel, which is kind of very exciting, right? So basically, in order to understand how we are actually going to do that, I'll take you to some of the high school chemistry knowledge. So think, we drink water every day. You have bottles of water, right? Half filled or full filled. But really, in each of, in this glass full of water, right? There could be, can anybody guess how many amount of water molecule could be present? Any numbers? Sorry, what did you say?
Millions of molecules.
Millions. Great. Any other guesses? Trillions. Wow. I would say it's 10 to the power 23. Right? 10 to the power 23 number of water molecules present in 1 mole of water. And I would say 1 mole is nothing but 18 grams of water. Right? So many water molecules present, but really it all comes down to the chemistry of one water molecule, which I'll show you here. If you just zoom in, this is our water molecule, which has really simple formula H2O, right? It has an oxygen in the middle, oxygen atom in the middle, bonded with 2 hydrogen atoms. So it's like a friendship between this oxygen and hydrogen to make a bond to make the full water molecule. So there's a bond, like they are really close friends. So if anybody of you can guess, now we have the structure of water, and our aim is to make hydrogen from this water. Can anybody of you guess how are we going to do that? Any answers?
Giving some energy to exciting.
Great answer. Excite to do what? What we want to do?
Break bonds.
Perfect. So we really want to break this bond, right? So now we have learned about the structure of water. So as you have all guessed, how do we generate hydrogen? So we really want to break the friendship, right, between oxygen and hydrogen to separate hydrogen and oxygen, right? So what we do, we need to put some external energy in form of electricity or any source of energy. To basically, that energy source should be greater than the energy between 2 bonds, right? If you want to break, I'm just joking, if you want to break a friendship, you really need to have some other source which is stronger in terms of their opinion to break that friendship, right? For some good purpose, right? So that's what is the basic concept of generating hydrogen as a source of fuel from water. All right? And this process is called as water splitting or electrolysis. What does electrolysis mean? Electrolysis, if we separate, it's basically 2 things, right? Electricity coming from electro part, and plus, which is equal to electricity plus lysis. If you are from biology, I think you might have heard about cell lysis, cell breaking, right? Lysis is just really the breaking of the cell. Here we are talking about the breaking of water to generate hydrogen and oxygen, right? So basically, that's what the concept is. You really take a mug of water, put the graphite pencil to make it conductive, and just connect it with the battery of any volt to provide external source of electricity. And you will see on the tip of graphite, the water will split into hydrogen and oxygen. You will see the generation of bubbles. And basically this hydrogen can be then taken to use as a fuel in your rocket or in your cars, and oxygen, everybody knows, can be useful for survival, right? So this is how you can take the wastewater from all over the world to create into hydrogen and oxygen as an energy carrier, right? So I believe that videos are louder than words, so I just want to play 1-minute video, and probably that will help you understand a bit better on how do we generate water from fuel from water. transfer bubbles of oxygen and hydrogen. Steam in a minute or fuels in a minute. So I will just, thank you. I'll just cover the summary that in today's lesson we understood and learned about the structure of water molecule and potential of abundant water to generate, and we applied our learning to perform the electrolysis of water. So thank you so much for listening, but really for the next session I would like you to all to think how much volume of hydrogen and oxygen will be produced from a 10 liter of water. Thank you so much for listening.